Hey everyone, welcome to Code Harmony. Today we are going to solve this LeetCode challenge 2657. Find the prefix common array of two arrays. This problem has been asked in the companies like Yandex, Amazon and Bloomberg. Let's try to understand the problem statement. Here you are given 0 index integer permutations of a and b of length n. Okay, these a and b are some kind of permutations. If you look on the constraints now, we will see that a and b are going to have values from 1 to n. We are given two arrays a and b. Both the arrays are going to have values from 1 to n, both inclusively. And also the array size is n. It means they are going to use all the values 1 to n in a permutated fashion, in a shuffled way. So shuffle these values, you will become a, and shuffle these value, it will become b. Okay, these two arrays are given to us, and they are also saying that there is some kind of prefix common array. What is prefix common array? Prefix common array of a, b is c, such that ith element in the prefix common array is equal to the count of number that are present at or before index I in both a and b. I will explain this question to you with the help of an example. Two arrays are given to us, array a and array b. Okay, and these two array are of length n, and these are just the permutation 1 2 3 4 in this linear way, and 3 1 2 4 just a permutation of a. This is the given part, and we can do some kind of operation, and after those operation we have to return this value. And what is this value? This is the answer array. Answer array is also going to have 4 items, 1 2 3 4, and every item, let's say answer I item, is the count of common elements in both the given array. Let's say we are processing this index. This index is I equal to 1. It means from index 0 to 1, both inclusively, in both the array a and b, count the common elements. From 0 to 1, 0 to 1. Here 1 is common. 2 and 3 are different. 1 is common. 1 is present in both the part. So answer 1 will be 1. And what about if I equal to 0? If I equal to 0, then till 0 index, what are the common elements? First one is having 1, second one is having 3. There is no common element. So in this way we have to fill this answer array. So this is our problem statement. The given part, the output is this, just output the answer array. And how do we prepare the answer array? For every ith item in our answer or in our prefix common array is the number of items which are present in both a and b. As the problem statement is clear to you, we will be going to have look on two approaches. This is the first approach, and both the approaches will be very easy to understand, and you will be able to write the code by your own comfortably. Okay, let's have a look on the first approach, and I am going to take this example. This is my A array, this is my B array, and both the arrays are of size n and values from 1 to n. N is 4 here, so 1 to 4 in both the array. Okay. So what is my first approach? I am going to take a hashing on the first array. See, what I need to prepare is get the ith item in my answer array such that from 0 to I, both inclusive, count the common elements in both array A and array B. If I try to form the answer, let's say this is the answer, and this is going to have 4 items, 1 2 3 4. What is the first item? First item is the index 0. It means this array and this subarray. This subarray marked as 1, from 0 to 0, 0 to 0. What are the common elements? I don't see any common element. First one is having 1, second one is having 3. So there are 0 common elements. Now just increase this subarray size from index 0 to 1. From index 0 to 1, what are the common elements? 3 is common, 1 is common, 2 items are common. Index 0 to 2. How many common elements are there? 3. And till the end, we are having 4 common elements. So this is going to be my answer, and this array I have to return from my function. So this answer array we have to fill, and we will be filling this array one by one, going from left to right for index 0 till n minus 1. Okay, how do we fill this? What we have decided is that we'll just somehow take the hash of the first array. What is hash? You can say the frequency count. If I maintain a frequency count of the first array values are going from 1 to 4, or you can say 1 to n. If the values are going from 1 to n and no value is getting repeated, let me just take a array of size n plus 1. So I can utilize the index 0, 1, 2, 3, 4. I can utilize indices 1, 2, 3, 4 to store the count. And yeah, I have to go from 0 to n minus 1 direction. Okay. So as we are starting my index I from 0 to n minus 1, when I'm at index 0, what I can do is I can process the frequency using a element, and I can see how many elements of B are common with A. Let's say when I am at index 1, the frequency of 1 is 1. So this will having 1, and what I can do is I can go from 0 to 0 because 0 is my I. I can run another loop. What I'm saying is that J pointer is going from 0 till I. J pointer is going from 0 till I, which is 3. So 3, I will see whether 3 is common or not. If 3 is common, it will definitely be present in this frequency array. 3 is not present in the frequency array. So at 0 index, there is no common element. Let's move to the further cases. Index 2. Index 2, the 3 frequency is increased. Frequency of 3 is increased, and here item is 1. I will see whether the item is 1. So what I will do is I will run another loop J. J will be covering every single element of B till ith index, and it will see whether that item is common with A or not. Whether 3 is common. Yeah, 3 is common because 3 frequency is 1. 1 is also common. 1 frequency is 1 in the hash array. So it will be 2. Now move ahead. I am moving ahead with I equal to 2. 2 frequency of 2 we have to increase. Frequency of 2 is increased to 1. And in this case, going from J is going from 0 to 2. 3 is common. 1 is common. 2 is also common. So it is 3, and similarly it is 4. Okay, so this is my approach. Pretty simple. So what I did is, first of all, I captured the frequency of A. Then I iterated on the array from 0 to n minus 1 with I pointer. And for every I in the J array, in the B array, I will run another loop from 0 to I, both inclusively, just to check how many elements are common. Because in this case, we have captured the frequency of A only. Now let's try to analyze the time and space complexity of this approach. What is the time complexity? First of all, I did one operation of capturing the frequency. And the capturing the frequency and processing the answer can be done in the same loop. In this loop, where I value is going from 0 to n minus 1. So this loop is going to run around n times. And this J loop is also linear because it will be running from 0 to I all the time. So in short, it is a quadratic time complexity, n into n approximately. Or we can say n is equal to, at time equal to n square. What about the space? Space is also order of n because we have taken extra space to store the frequency. What is the space? Space is order of n. So this is our first approach, where we are able to solve this problem in order of n square time because we have captured frequency of only A array. This is the code for our first approach. We are having 2 arrays given to us, and I'm using for outer loop for I pointer. I pointer is going from 0 to n. And while moving in this direction, I'm capturing the frequency of A array. Frequency of A array is being captured, and for the array B, I'm going to see from index 0 to I. You can use another pointer for this. In pointer J will go from 0 to I. I will see how many elements are common in both A and B. A frequency is already captured in this hash array, and I will see whether the B is already available in the hash. So all the common elements I can add in the answer I. This statement can be after this for loop, but yeah, that is also going to work. So this was my first approach, where we have taken n square time and a linear space. Now let's have a look on the second approach. To understand the second approach better, you need to have a look on these factors. Let both the array are of size n. And if both the arrays are of size n, both the arrays are going to have values from 1 to n, both inclusively. And this is also 1 to n, both inclusively. And none of the array is getting any duplicate element. So first array is also going to have 1 to 4 element. Second array is also going to have 1 to 4 element. If I take a hash array, every item is going to have frequency, maximum frequency equal to 1. And here in this case, both for the second array as well, the frequency of any ith element having a maximum value of 1. So frequency of any element from array A is having a maximum value of 1. Maximum value of 1. If I just take a common hash array, if I take a common frequency array which is capturing frequency of both A and B, in this case, what is the maximum possibility value, maximum possibility of any frequency? That is 2, because any element can be from one array or second array. Let's say what are all the different possibilities of any frequency? If we are moving in this direction, initially it is always 0. Then after some time it might be 1. And once we have completed both the array, it will definitely be 2. So at any instant, we are going to have 3 possibilities. What does this possibility say? It means the element has appeared in A and B, both the array. A and B. What does 1 mean? Either it is in A or it is in B. It has not been appeared in any one of this array. So what is the core of this approach? Taking a common hash array. 0, 1, 2, 3. Let's say this is my hash array and I'm going in this direction from index 0 to n minus 1. When I come to index 1, what is the frequency? Frequency of A is 1. 1 is 1 frequency, 3 is 1 frequency. None of the frequency is 2. Okay. Now when I move to the next item, so here in this case, we'll just also maintain the counter. Answer is going to have how many 2 frequency you have encountered so far. So far at this index 0, there is 0 2 frequency we have encountered. Okay, let's move ahead. Index 1. At index 1, the frequency of 1 has become 2 and 3 has become 2. 1 has become 2, 3 has become 2. How many frequency equal to 2 we have encountered so far? Till index 1 we have encountered 2 frequency with value 2. When I is equal to 2, frequency of 2 is increased by twice. 2 has become 2, and now my counter is generic. So counter is initially 0, then at 1 index it has become 2, and then after at 2 index one more 2 has appeared, so it has become 3. So till index 2, common elements we have encountered is 3. At index 4, the common elements we have encountered is 4. Now in the at index 3, the item is 4. The frequency of 4 is increased by twice, and this counter is also incremented because one more 2 frequency we have encountered. So it is 4. So this is the approach. In short, we are maintaining a common hash function, and whenever we are capturing a frequency of 2, we will see that there is one common element we have encountered till ith index. This is the code for my first approach, but now we are going to take a common hash function. Common hash function, it means this hash function itself is going to store frequency of array A and B. Array A frequency it has captured, and now array B frequency it will also capture. And after capturing the frequency, we need to see whether the frequency is becoming equal to 2. If hash of A of I is becoming equal to 2, what I need to do is I need to increment some kind of counter. Similar to in this case, if hash of b of I is becoming equal to 2, counter is incremented, and counter is generic. Int counter is equal to 0. And now in this case, we are maintaining counter. What is the counter? Counter is count of 2 frequencies so far from starting to this moment. So answer I is equal to number of frequencies which is equal to 2 we have encountered so far. So that is equal to counter. That's all we have to do. Let me run over sample test cases. counter. Sample test cases are passed. I'm submitting the problem. It's submitted successfully. I hope you understood the approach. And in this approach, we are not taking quadratic time. In the previous approach, we were taking quadratic time. So we are using only one loop. So its time complexity is order of n. And what is our space complexity? Same. Linear space, linear time. Okay. Thank you guys. Bye.